All right, so we're in section 12.4 where we're going to find the sums of infinite geometric series. Now, in section 12.3, we were able to use an equation for finding geometric series in a finite state, which means it had a certain stopping point. Here today, those series are going to go on and on to infinity, some of which will have an actual sum because as your common ratio gets to be at a certain point at when the pattern becomes extremely large or extremely number of values, you're going to get so many numbers at a certain point where it's going to approach a certain value. And I'm going to kind of show you what that is, maybe not with using infinity, but with using some extremely large number. So if you look at the graph here with example A, what they want you to do is they want you to graph the partial sums of S of n using n as 1, 2, 3, 4, and 5, and then describe what happens when S becomes extremely, increases really, really large. So if you remember from yesterday, our uh, our equation to find a finite series was S of n equals whatever a sub 1 is to the 1, oh shoot, to the 1 minus r to the n power divided by 1 minus r. So if I look at this pattern here, if I go 2/3 divided by 2, it looks like I get a common ratio of 1/3. 2/9 divided by 2/3, that also is 1/3. So my r, in this case, is going to be 1/3. So if I put it into this sequence, I get a sub 1, which is 2, times it by 1 minus 1/3 to the nth power. Well, we want to know what it is to infinity, so we'll just kind of put infinity right here, divided by 1 minus 1/3. So there is no 1/3 value that you can punch in on your calculator, but say you did something like this. Say you took 1/3 to some really big power, like say like take it to the 10,000th power. If you did that on your calculator, you would get a value of 0 because it's something that's so many decimal places off the grid that it's like, you know what, it's so close to 0, let's just make it 0. So if we do that, I can say that this is 2 times 1 minus 0, which is 1, divided by 1 minus 1/3, so it's going to give me 2/3. So 1 divided by 2 divided by 3, which is going to give me, what, 3 halves, times that by 2, which gives me 3. So s is when s is approaching infinity, it's going to equal 3, which which makes sense. So if I were to put this on the graph, uh, my x coordinates represent my sequence. So this is going to be like my s of 1, s of 2, s of 3, and so on. So if s is 1, my value is going to be 2. If my s is 2, it's going to be 2/3, so it's somewhere right around here. If my s is 3, it's going to be 2 over 9, 2 over 27, so on and so forth. It's getting really, really close to 0, and it's going to keep going like that on to infinity. So when you add those together, most of the time you're gonna get values really close to 0. So as s approaches infinity, the sum for this case is going to be 3. So now you don't necessarily have to use this formula. We have a new formula that's going to help us find what the infinite geometric series is. So if we know what the first term is, which is a sub 1, we can find what s to infinity is by taking a sub 1 divided by 1 minus r. it only works as long as r, the absolute value of r, excuse me, is less than 1. And if we find ourselves with an absolute value of r that's greater than or equal to 1, our series has no sum, or it's just going to go on to infinity. So the only time we can ever use this formula is when r is a fraction that's in between 0 and 1. So if I look at example A, I have, my series is going on to infinity. Remember from our equations, this is going to be my a sub 1, and this is going to be my r in this case. So if I use the formula, I'm going to go s equals 3 divided by 1 minus 1/4. And when I do that, s here is going to equal, was it 1 minus 1/4 is what 3/4. So 3 divided by 3/4 is going to give me 4. Okay. If I look at this one here, I see that I'm going to have s equals, what, negative 1/2 divided by, so if I go 1 divided by 4 divided by negative 1 divided by 2, that's going to give me a negative 1/2 here, so it's going to be 1 minus a negative 1/2 minus negative 5, so it's going to be what? Negative 0.5 divided by 1.5, which is giving me what, negative 1/3. So s here is going to be what, negative 1/3. And for c, I notice that my r, it's 5/4, which is greater than 1. And since it's greater than 1, our rule states that if it is, this one's going to have no sum. Last thing, I didn't have it in the notes, but you will have some questions on it in your homework that you're going to have to be able to write repeating decimals as a fraction. So, for example, say I had 0.4 repeating, and I wanted to write that as a fraction. Here's how I kind of want you to solve this. You almost kind of get to treat it like a geometric series going to infinity. So I can say that 0.04 repeating equals 0.4 plus 0.04 plus 0.004. And if you add those together, you'd still just get a 4 in each of those digits, and I can go on to infinity. So what you can do is you can use the equation for the series, which then equals, the top's going to be a sub 1, which is 0.04, or 0.4, I'm sorry, divided by 1 minus whatever r is going to be. So r is going to be dictated by 0.04 divided by 0.4, which gives me 0.1. Well, this is going to be 0.4 divided by 1 minus 0.1, which gives me 0.9. Put those in the lowest terms. My fraction is going to be 4/9. Okay. Excuse me. And that is being able to find the sums of infinite geometric series. Hope this helps. Till next time.